In this video, we'll be learning how to simplify complex fractions. So before we begin simplifying complex fractions, we need to discuss what a complex fraction actually is. By definition, a complex fraction is a fraction that contains a fraction in its numerator and or denominator. So basically what this means is we have a fraction within a fraction. So an example of a complex fraction might look something like this. So it means we might have something like 5x plus 2 over x plus 1/2 over 3x minus 3 over x minus 2. So if you look at this, you'll notice we have fractions within a fraction. We have a really big fraction here with the large separation, but then we have little mini fractions inside of the numerator and or denominator. So that's what a complex fraction looks like. Now when we're simplifying these complex fractions, we're going to take the same 3 steps pretty much every time. First, we're going to simplify the numerator by writing it as a single fraction. So that means in this example, we would use our knowledge of adding fractions and how to add rational expressions like this to simplify that numerator. Then we do the same thing to the denominator if needed. In this one, we wouldn't need to, but in some, you'll need to simplify both the numerator and the denominator. And then from here, we use rational division to divide the two fractions. So let's jump in and try our first example. If we look at the numerator, we can see that this one is already condensed down to a single fraction. So we don't actually have to do any simplifying there. But where we do need to do some simplifying before we can actually deal with the big fraction is down here in the denominator. So what I'm going to do is I'm going to focus on simplifying this piece right here on its own. So we have 3 over x plus 4 plus 2 over x. And in order to condense this down into one single fraction, I know that I need to get common denominators because I'm adding these two fractions together. So when I look at this, I notice that in order to get a common denominator, I essentially need to multiply both 3 and x plus 4 times x. And then I need to multiply the 2 and the x by x plus 4. And in doing so, I'm going to have a common denominator of x plus 4 times x, so both of those items will be in the denominator. And then we will also have in our numerator 3 times x plus 2 times x plus 4. So because they now have common denominators, I can add the two numerators together. So this will simplify just a little bit further if I distribute. So if I distribute the 2, I end up with 2x plus 8. So my numerator becomes 5x plus 8 over x plus 4 times x. And I can put the x in parentheses or not, it doesn't matter because the x is just by itself. So now I'm going to go back to my big fraction here. So I have 5x over x plus 4 all over my big fraction, 5x plus 8 over x plus 4 times x. So now that I have the numerator and the denominator simplified to be one simple fraction in each, now I can actually perform rational division. So what I'm going to do to start is I'm actually going to rewrite this because this big fraction sometimes can be a little bit tricky to look at. So I'm going to write this as 5x over x plus 4, and then I have the fraction means division, so divided by 5x plus 8 over x plus 4 times x. So that just makes it a little bit easier for me to look at. Now I know that I can rewrite any division problem into multiplication by multiplying by the flipped version of the second fraction. So here this is going to become 5x over x plus 4 times x plus 4 times x in my numerator, and then 5x plus 8 in my denominator. now that I have a multiplication problem, I know that I can simply multiply across and then cancel out any common factors that they have in common. So here, this would become 5x times x plus 4 times x. And then in my denominator, I would have x plus 4 times 5x plus 8. So here I see that the x plus 4 and the x plus 4 cancel out. I also notice that 5x and x can be combined together to be 5x squared. So that's what I'm going to put in my numerator. So I have 5x squared in my numerator with 5x plus 8 in my denominator. This doesn't simplify any further, but I do need to note that x cannot equal negative 4 because I crossed that out of the denominator. So there we have our final answer. So now let's try an example where we have to simplify both the numerator and the denominator. So here, if I take a look at this first example, I notice that my numerator has 2 fractions. I also notice that it's subtraction this time, so I'm going to turn this into an addition problem by distributing that negative 1 to every number in the numerator. So now that I've got this turned into addition, I'm going to get common denominators. And I notice that I have a denominator of 5 and a denominator of 4. So the easiest way to simplify this is to multiply both the numerator and the denominator in the first fraction by 4, and the numerator and denominator in the second fraction by 5. So here this becomes 24x over 20 plus negative 15 over 20. And now, because I have common denominators, I can add these together to get 24x minus 15 all over 20. So now let's take a look at the denominator. Again, I notice that I have a subtraction problem, so I'm going to turn it into addition by multiplying both numbers in the numerator of the second fraction by negative 1. So this becomes negative 3x, and this becomes a positive 1. Then from here, I know that I need to get common denominators, and I notice I have denominators of 8 and 15. So I'm going to multiply both the numbers in the first fraction by 8. So that gives me 24 over 120. And then I'm going to multiply this entire numerator by 15, as well as the denominator by 15. So this becomes, if I distribute the 15 in there, a negative 45x plus 15 over 120. And now, because I have common denominators, I can add these together, and they will become negative 45x plus 39 all over 120. So now that I've simplified both my numerator and my denominator, I now have one single fraction here. In my numerator, I have 24x minus 15 over 20. And in my denominator, I have negative 45x plus 39 over 120. So now from here, I can simplify this by turning it into a division problem and using rational division. So if I turn it into a division problem, I end up with 24x minus 15 over 20 divided by negative 45x plus 39 all over 120. And then I know I can turn any division problem into multiplication by multiplying by the second fraction's reciprocal, which basically just means I flip it over. So this becomes 24x minus 15 over 20 times 120 over negative 45x plus 39. So now what I need to do in order to simplify this is I need to use my simplifying techniques in order to simplify this rational expression. So what I'm going to do is I'm going to factor out as many things as I can. So when I look at this first one here, I notice that both 24x and negative 15 are divisible by 3. So I'm going to rewrite that to be 3 times 8x minus 5. And then I still have the times 120 over here. The 20 I leave alone. Here, I'm going to see if I can get this to have a positive x value. So I'm going to factor out a negative 3. So if I factor out a negative 3 here, I end up with 15x plus a negative 13. So now I can kind of start to condense these down just a little bit. I also noticed that if I were to start simplifying things now, the 3 and the negative 3 are really close to canceling out. This would simply become a 1, and this would become a negative 1. So the 3's can cancel as long as this becomes a negative 1 as I simplify. The 120 and the 20, these cancel out as well because 120 is divisible by 6. So we can now simplify this down to be a 6 in my numerator times 8x minus 5, all divided by, we have negative 1 times 15x plus a negative 13. Or you can have minus 13, it doesn't matter. So we were able to simplify that quite a bit just by getting one fraction in the numerator, one fraction in the denominator, and then using our knowledge of rational division. So let's try one final example here. So again, I need to focus on numerator first, then denominator, and get them simplified to one single fraction. So here, if I focus on my numerator first, I notice that I have an addition problem, so I don't need to do any modifying. And then I need to get common denominator. So I'm going to multiply both the numerator and denominator of the first fraction by 4, and multiply the numerator and the denominator of the second fraction by x minus 3. And in doing so, I'll be able to get common denominators. So I'm going to distribute out that 4 as I do that. So I have 24x plus 4 over, this becomes 4 times x minus 3. Then I have plus, distribute the 3 here, I have 3x minus 9 over, again, I have 4 times x minus 3. Now because I have common denominators, I can add those numerators together. So I can combine any like terms as I do so, and I end up with 27x minus 5 over 4 times x minus 3. So now if I look in my denominator, I'm going to kind of go through the same exact process. So I'm going to multiply this 3 by x minus 3 and the 8 by x minus 3. Then I notice that this is subtraction, so I'm actually going to change every number in the second numerator of the second fraction by multiplying it by a negative 1, so I can turn this into addition. So that becomes a negative 4x and a positive 2. And then I'm going to multiply both of those by 8, so I get the denominator of the other fraction. So now if we start to simplify a little bit, distribute the 3, we get 3x minus 9 over 8 times x minus 3. Then plus, we distribute the 8, we end up with negative 32x plus 16 over 8 times x minus 3. Then from here, we can simply combine and add together the like terms that we see in the numerators because we have common denominators, and we end up with negative 29x plus 7 in our numerator, and then we have 8 times x minus 3 in our denominator. So what we now have is one singly large fraction of 27x minus 5 over 4 times x minus 3, then all over in a big fraction, negative 29x plus 7 over 8 times x minus 3. So now I can turn this into a division problem. So let's rewrite this a little nicer. So we have 27x minus 5 divided by 4 times x minus 3. And then we have all of that divided by negative 29x plus 7 over 8 times x minus 3. Now I can turn this into multiplication because I can just multiply by the reciprocal of the second fraction, which means I'm going to flip it over. So if I give myself a little more space here, I end up with 27x minus 5 over 4 times x minus 3 times 8 times x minus 3 over 29x plus 7. And then if I just multiply across, that's 27x minus 5 times 8 times x minus 3 over 4 times x minus 3 times 29x plus 7. So at this point, I can now start canceling off anything I see in common because they are going to be able to cancel out now that I have a really big multiplication problem. So I have x minus 3 and x minus 3 that can cancel out. I also notice that the 8 and the 4 can become 2 over 1, so I can simplify that a little bit. So as a result, I'm left in my numerator with 2 times 27x minus 5. And in my denominator, this 1 doesn't really impact the 29x plus 7 at all, so it's just 29x plus 7. So that's my simplified expression here. It doesn't simplify further because nothing factors further. And then I need to note that x cannot equal 3.